Deep beneath the crust of our planet, hidden inside ancient rock that predates all recorded history, scientists have uncovered evidence that does not fit within the accepted story of life on Earth. Tiny metallic spheres, microscopic beads laced with rare elements, lie scattered across strata dating back 65 million years, the same age as the rock layer that marks the end of the dinosaurs. Their chemical composition mirrors residues produced by modern nuclear detonations, yet they were created long before humanity ever learned to split an atom. The discovery forces an uncomfortable question. Could traces of technology exist in epochs when humans were not even a dream of evolution? For generations we have believed that our species is unique, the first to extract metals, burn fuels, and engineer the planet's chemistry. We assume that the Industrial Age was the first moment intelligence truly reshaped the Earth. But what if that assumption is wrong? What if civilizations rose and fell long before ours, their works reduced by time until only a few atomic echoes remain? Geological time is an unforgiving editor. Mountains rise, oceans swallow continents, and entire biospheres vanish without leaving fossils. In the immense ledger of Earth's history, even 1,000 centuries barely registers as a footnote. If another technological society once thrived here, erosion and subduction would have erased its cities, melted its machines, and recycled its bones into the crust. Only the most stubborn fingerprints, those written in chemistry and isotopes, could survive. Imagine trying to detect a single heartbeat that occurred millions of years ago by listening to the faint vibration still trembling through stone. That is the scale of the mystery. The metallic spheres discovered in ancient sediments appear too deliberate to dismiss as coincidence. They contain patterns of distribution identical to fallout from modern industrial pollution, forming a global dusting across multiple continents. When researchers first analysed them, they assumed volcanic origin or asteroid debris. Yet their isotopic ratios do not match any known natural source. Each sphere tells the same story. Matter once exposed to temperatures and pressures that only deliberate technology could generate. The finding does not prove the existence of an earlier civilization, but it opens a door we have long kept locked. For the first time, scientists are forced to ask whether intelligence might have emerged, flourished, and perished long before humanity arrived. Every epoch leaves its mark. The dinosaurs left bones, plants left coal, and humanity is leaving a geological signature of plastics, carbon dioxide, and radioactive isotopes. If future beings studied our ruins millions of years from now, they would find unmistakable evidence of our industry, thin layers of artificial elements and synthetic compounds embedded in rock. The question is whether we, the investigators of the present, are already walking over similar evidence left by predecessors we have forgotten. To explore that idea, researchers look for what they call techno-fossils, physical or chemical remnants that could not arise without deliberate manipulation of nature. These remnants need not be intact machines or artifacts. They might be molecular arrangements, isotopic anomalies, or synthetic compounds unknown to natural processes. The challenge lies in recognizing them. A signature carved in stone can endure, but only if one knows what pattern to look for. Our current knowledge is biased by the technology we ourselves use. We recognize the byproducts of combustion and radioactivity because we manufacture them daily. Yet an older civilization might have drawn its power from mechanisms or energies we do not yet understand, leaving traces we cannot identify even when they sit beneath our microscopes. Consider how much of human activity would vanish if observed from a future 10 million years away. Skyscrapers would crumble, roads would dissolve, even steel would revert to oxide dust. All that might remain are subtle chemical scars in clay and sand. Now invert that thought. What scars could we be mistaking for natural features simply because we lack the context to see them as technological? The concept unsettles both scientists and philosophers because it undermines the notion of human exceptionalism. If intelligence can appear repeatedly on the same world, then we are not the planet's first experiment with consciousness, merely the latest iteration in a cycle measured not in centuries but in eons. That realization transforms the search for extraterrestrial life into something more intimate. Instead of scanning distant stars for alien signals, we may only need to look beneath our own feet. Each new core sample pulled from the Earth becomes a potential message from a civilization erased by time. The metallic spheres are only the beginning. They whisper that matter remembers even when memory fails. They hint that the Earth itself is a palimpsest, a rewritten manuscript where earlier chapters lie faintly beneath the text of the present. And they remind us that the deeper we dig, the closer we come to confronting a possibility both thrilling and terrifying, that intelligence is not a one-time miracle, but a recurring force of nature, destined to rise, fall, and rise again. Perhaps the greatest discovery waiting beneath our feet is not proof of alien life, but evidence that the Earth has dreamed our story before, countless times, each ending swallowed by the silence of deep time. In the late 20th century, a geologist named Walter Alvarez stumbled upon a clue that would change the way we perceive Earth's deep history. While studying the layered limestone of Gubbio, Italy, he discovered a thin band of clay sandwiched between rocks separated by millions of years of evolution. Above the line lay fossils of mammals and flowering plants, the era of recovery. Below it, the bones of dinosaurs and creatures that had ruled the planet for 100 million years. But inside the clay itself was something extraordinary, a dense concentration of iridium, a metal rarely found on Earth's surface but abundant in asteroids. This narrow, unassuming strip of soil turned out to be the fingerprint of apocalypse, the residue of an asteroid impact so immense that it erased 75% of life. The revelation proved that cataclysms leave signatures lasting longer than any species. Long after bones decay and monuments crumble, the chemistry of destruction remains etched into stone. It was this realization that inspired a haunting thought. If humanity were to vanish tomorrow, what would mark our existence 50 million years from now? Would the next intelligent beings, if they emerged, find a similar strange layer, a boundary laced with radioactive dust, synthetic compounds, and carbon residues telling the story of a species that mastered fire and then burned itself out? Alvarez's discovery revealed that the planet itself is an archive, one that remembers catastrophe more faithfully than creation. Every major transition, the rise of oxygen, the spread of forests, the fall of empires written in geology rather than ink leaves a physical trace. But the archives of Earth are incomplete, fragmented by erosion, subduction, and metamorphosis. The deeper we look, the more pages appear missing, as if some ancient editor tore out entire chapters of history. Perhaps within those lost chapters lie records of civilizations that rose before ours, erased not only by cataclysm, but by the relentless rewriting of the crust. Scientists studying the iridium layer began to wonder what other anomalies might be waiting in forgotten rocks. They started to reinterpret chemical and isotopic signals once dismissed as natural curiosities. Some layers rich in heavy metals, some odd spikes in carbon isotopes, some sudden global extinctions, they all could be read as possible techno-signatures, faint hints that intelligence may have tampered with the planet long before recorded history. The Alvarez impact theory opened the door for a new way of thinking about the past. It reminded us that the story of life is punctuated not by steady progress, but by abrupt resets, moments when nature or perhaps intelligence itself presses the button and starts again. If a civilization had existed before ours, its end might resemble that of the dinosaurs, a flash of light, a wave of fire, and a layer of dust infused with the evidence of technology. The geological record would not care whether the cause was an asteroid or an experiment gone wrong. To the stone, both are identical. The key insight from Alvarez's work is that the planet keeps score through chemistry. The amount of iridium in that clay layer is minute, yet it speaks louder than the fossils buried above and below. It proves that a single event lasting mere hours can alter the entire trajectory of evolution. That understanding forces us to look at our own industrial era with uncomfortable clarity. In just 2 centuries, humanity has produced enough synthetic materials, isotopic changes, and atmospheric shifts to mark the crust forever. Future geologists, human or otherwise, will find our layer unmistakable, the Anthropocene boundary. But if that's true for us, might similar boundaries already exist deeper down ancient Anthropocenes whose architects are long gone? Alvarez himself never claimed such a possibility. Yet his discovery unknowingly gave later scientists the conceptual tools to ask it. If an asteroid impact could be recognized 65 million years later, so too could the chemical legacy of an ancient civilization. All we need is to learn the language of the rocks. The deeper researchers drill, the stranger the signals become. Some strata reveal unusual isotopic ratios that hint at combustion on a massive scale. Others show abrupt global temperature spikes inconsistent with volcanic activity. Each clue can be explained by natural processes, yet taken together, they form a pattern that feels disturbingly familiar, an echo of industrial behavior. It's as if the Earth itself remembers a previous experiment in civilization, now compressed into stone. The iridium layer stands as both evidence and metaphor. It reminds us that cosmic or technological disasters leave indelible scars, and that intelligence, no matter how advanced, cannot escape geology's judgment. The impact that ended the dinosaurs gave rise to mammals, and eventually to us. But perhaps we too are only an interlude before another layer forms, another record of ambition turned to dust. Alvarez's thin band of clay is more than a relic of death. It is a mirror, showing us how fragile our presence truly is in the face of planetary time. Every civilization, whether born of nature or reason, writes its own obituary into the rocks. The only question that remains is how many such obituaries the Earth already holds, waiting for someone curious enough to read between the layers. In 2018, two scientists from NASA and the University of Rochester, Gavin Schmidt and Adam Frank, posed a question that seemed more like science fiction than geology. If an industrial civilization had existed millions of years before humans, would we be able to detect it today? They called this thought experiment the Silurian hypothesis, named after a race of intelligent reptiles from old British television. The question was not whether such a civilization actually existed, but whether our planet would even remember if it had. Imagine a society that burned fuel, mined metals, built cities, and eventually disappeared tens of millions of years before humanity evolved. After so much time, would any recognizable trace remain? According to the hypothesis, almost nothing physical would survive. Skyscrapers, vehicles, and satellites would crumble within tens of thousands of years. Erosion, subduction, and biological decay would recycle everything back into the planet. The only evidence might be hidden within the chemistry of sediment's subtle shifts in isotopes, strange concentrations of heavy metals, or synthetic molecules that do not occur in nature. These are what Schmidt and Frank called technosignatures, indirect whispers that intelligence once altered the planet's balance. The power of the Silurian hypothesis lies not in proving an ancient civilization, but in challenging our assumptions about permanence. We tend to imagine that our technology will last forever, that our monuments are eternal. But Earth's geological processes are relentless. In a few million years, nearly all surface traces of humanity would vanish. Even our greatest structures, the pyramids, the Great Wall, the vast cities of steel and glass, would erode into dust and eventually be folded back into rock. The fossil record is extraordinarily incomplete, preserving less than a fraction of all species that ever lived. If life itself struggles to leave a mark, what chance does culture have? The hypothesis asks us to look at the deep past with fresh eyes. If we found evidence of sudden climate shifts, massive carbon releases, or global extinction patterns, would we automatically attribute them to natural causes? Or might some of them represent the unintended consequences of an earlier civilization's industrial age? For example, a rapid spike in carbon dioxide could be caused by volcanic eruptions, but it could also be the geological shadow of a society that burned fossil fuels long before we did. The distinction is subtle, and over millions of years the clues blur together. Schmidt and Frank emphasized that our own civilization, if erased today, would leave an unmistakable layer in the rocks, a thin band rich in plastics, radionuclides, and synthetic chemicals. Future geologists could identify it immediately, even if they knew nothing about humanity. Yet, if a previous civilization's industrial layer lies buried far beneath us, it may have been transformed by heat and pressure until its signals mimic natural patterns. The deeper we go in time, the harder it becomes to tell intelligence from accident. The Silurian hypothesis therefore transforms the search for ancient life into a kind of detective story. Instead of digging for fossils, we search for patterns, anomalies that make sense only if some force once engineered them. Scientists point to mysterious events such as the Paleocene-Eocene thermal maximum, a sudden global warming episode 56 million years ago, when temperatures soared and carbon isotopes shifted dramatically. It could have been caused by volcanic outgassing or perhaps something else. The hypothesis doesn't claim to know, but it forces us to consider that Earth's past may be more layered than we think. Every civilization, including ours, inevitably leaves behind chemical footprints. The question is not whether they exist, but whether we are capable of recognizing them. To an archaeologist, an artifact is proof of culture. To a geologist, the artifact is chemistry itself, the subtle imbalance of elements frozen in stone. And to a philosopher, the real artifact might be the repeating pattern, intelligence arising, transforming its environment, and then vanishing, leaving behind only a whisper of order amid chaos. Schmidt and Frank's paper sparked debate across scientific fields. Some dismissed it as a clever thought experiment, a metaphor for climate change disguised as speculative fiction. Others saw it as a profound shift in perspective, a recognition that Earth's story may include forgotten chapters of intelligence. If we could vanish so completely that future beings would struggle to find us, then how can we be certain we are the first? The Silurian hypothesis reminds us that time erases arrogance. It humbles the notion that history begins with us. It also reframes our relationship with the planet. If intelligence has arisen before, then perhaps nature itself tends toward consciousness, not as an anomaly, but as an inevitable outcome. Civilizations may come and go like tides, each one thinking it stands alone. The rocks tell another story. They show that nothing truly disappears, only transforms. Beneath our cities may lie the ashes of forgotten worlds, compacted into silence. The Silurian hypothesis invites us to listen to that silence, to search for intelligence not among the stars, but within the strata beneath our feet, where the ghosts of prior ages may still whisper through the minerals they once reshaped. In the end, the hypothesis is less about proof and more about perspective. It asks a single haunting question. If we are not the first, then what lessons did the last civilization fail to learn before it became just another layer of clay? The story of life on Earth is written not in ink or memory, but in the stone pages of the fossil record, a chronicle carved by pressure and time. Yet when we read that book closely, we find entire chapters missing. Abrupt transitions where new forms of life appear seemingly out of nowhere, and old ones vanish without explanation. These gaps have always puzzled scientists. The most famous of them, the Cambrian explosion, marks a period around 540 million years ago when complex organisms suddenly diversified in astonishing abundance. In geological terms, it happened overnight. Within a few million years, creatures with eyes, shells, limbs, and intricate nervous systems emerged after billions of years of microbial monotony. It is as if evolution had accelerated far beyond its natural pace, as though guided by some invisible catalyst. The conventional explanation points to rising oxygen levels and environmental change, but the magnitude of the leap continues to challenge our understanding. If natural processes alone were responsible, why did evolution remain nearly stagnant for eons before suddenly blossoming with complexity? The fossil record offers no clear answer, only silence between layers. It is within that silence that imagination begins to stir. What if the missing pages are not lost by chance but by design? What if there were events technological, biological, or even intentional that reshaped evolution in ways we have yet to comprehend? Some researchers have proposed that intelligence may have appeared not as a sudden miracle in the last few million years, but as a recurring phenomenon that occasionally rewrites the biological code of the planet. Genetic data shows patterns that appear oddly organized, almost engineered, as if life's progression has been nudged at critical moments by forces beyond simple mutation and selection. The Cambrian explosion could have been one such intervention, a reboot of the biosphere after an earlier system collapsed or transformed. Fossils, however, are terrible storytellers. They capture death, not intention. They record forms, not minds. Most species leave no trace at all. Soft-bodied organisms dissolve before they can be preserved. Entire ecosystems disappear without a single imprint. The deeper into time we look, the more uncertain the picture becomes. Even the most detailed fossil beds are like flickering frames of an ancient film missing 99% of its scenes. In that darkness, entire civilizations, if they ever existed, could have risen and fallen without leaving a visible trace. When paleontologists map evolutionary trees, they often find abrupt divergences, new species with no clear ancestors, sudden bursts of genetic novelty, or lineages that vanish completely from the record. These moments are usually attributed to environmental stress or random mutation, but some anomalies resist easy explanation. Certain microfossil layers show biochemical patterns inconsistent with natural development, almost as if the metabolic machinery of life had been modified in unison across vast ecosystems. If intelligence once existed in prehistory, not necessarily human, not even humanoid, it may have left its mark not in monuments but in biology itself. Perhaps the code of life carries encrypted memories of previous thinkers, encoded within DNA sequences that appear random but function like ancient programming. When new species emerged after extinction events, they might have carried echoes of design passed down from forgotten epochs. The fossil record's missing pages then become less about absence and more about transformation moments when the story was rewritten. Each great extinction could represent both an ending and a reset, a deliberate or accidental act of planetary editing. It's a concept that blurs the line between natural evolution and technological influence, between biology and engineering. To entertain it is to expand our definition of intelligence beyond bones and tools, to consider that consciousness might have once operated through means that left no artifacts, only genetic ripples. Some geologists suggest that what we call gaps may actually be layers overwritten by immense events flood basalt eruptions, meteor impacts, or chemical shifts, erasing the physical evidence of what came before. But what if some of those erasures were not accidents of geology, but deliberate acts of preservation or concealment? If an ancient civilization understood the fragility of its own existence, it might have chosen to bury its traces, to let its works dissolve into the mantle, rather than risk misinterpretation by its successors. After all, what better way to disappear than to become part of the planet's fabric? The missing pages might then be the result of a choice of civilization's final gesture of humility or survival. The fossil record, incomplete as it is, continues to whisper of patterns repeating over vast cycles. Life flourishes, transforms, and resets, each time emerging with new complexity, as if following a script too grand for any single species to comprehend. Perhaps the Cambrian explosion was not the first awakening of complexity, but merely the latest reboot of an ancient system that has risen and fallen countless times. We read the fossils as our ancestors, but maybe they are also our predecessors in consciousness, fragments of a planetary intelligence that renews itself again and again. The missing pages of the fossil record are not just voids in history, they are invitations to question the nature of progress, to consider that intelligence may not be a linear story from simple to complex, but a rhythm that beats across epochs, forgotten and reborn, each time rewriting the memory of Earth itself. Long before the first human breathed air, the planet's atmosphere was already a restless canvas, shifting through compositions that shaped and reshaped the destiny of life. Each transformation left behind a chemical echo, a fingerprint etched into the rocks and the ice. When scientists study ancient air trapped in minerals or polar layers, they find patterns that defy easy explanation: rapid changes in oxygen, carbon dioxide, and trace gases that occurred far too quickly for purely natural processes. The Great Oxygenation Event, for instance, transformed Earth roughly 2.5 billion years ago, flooding the sky with a gas that was once toxic to nearly every organism alive. Officially, it's described as a biological revolution, the byproduct of microbes evolving photosynthesis. But some anomalies within that event disturb the neatness of the story. Oxygen levels did not simply rise in a gradual curve. They surged and collapsed in violent pulses, as if controlled by something with feedback, precision, and purpose. To modernize, such oscillations resemble the fingerprints of industrial activity bursts of production, followed by crashes of collapse. It's not proof of technology, but it raises a haunting possibility. What if these ancient atmospheric fluctuations were signs of manipulation on a planetary scale, perhaps by life forms experimenting with their environment long before we appeared? Earth's atmosphere is an archive of chemistry and intent. In its layers, scientists have detected isotopic irregularities, suggesting sudden global heating and cooling, methane spikes, and inexplicable shifts in nitrogen balance. Some of these signatures correspond to known natural cataclysms, volcanic eruptions, or asteroid impacts, yet others appear detached from any known cause. They suggest massive releases of carbon and rapid recoveries that mimic the rhythm of modern climate engineering. It's almost as if, deep in the past, someone or something learned how to regulate the air itself, only to lose control or vanish before balance could be maintained. The Paleocene-Eocene thermal maximum is one of the most perplexing examples. Around 56 million years ago, global temperatures rose by 5 to 8 degrees in a geological blink. Carbon isotope ratios indicate a sudden release of immense amounts of greenhouse gases. Official theories range from volcanic activity to methane hydrate collapse. But the speed and precision of the shift, the layered sequencing of warming followed by a sharp stabilization, mirror the signatures of artificial forcing and experiment scaled up to planetary proportions. If such events were the result of a civilization's technology, the traces left behind would not be machines or structures, but chemistry itself. The altered ratios of carbon-12 and carbon-13, the rare isotopes of nitrogen and sulfur, the faint ghost of industry encoded in air and stone. The same reasoning applies to other mysterious transitions, the Devonian oxygen spike, the Triassic warming, the sudden appearance of sulfur anomalies unlinked to known volcanism. Each one could mark not only natural chaos but technological intervention, the efforts of some intelligence attempting to steer the climate of its home world. Perhaps these ancient beings, whatever form they took, tinkered with the delicate balance of gases to sustain their civilization, just as we now debate carbon capture and geoengineering. And perhaps, like us, they discovered too late that the system they sought to control had a life of its own. Atmospheric chemistry can preserve memory far longer than bones or buildings. The isotopic composition of air and sediment can remain stable for tens of millions of years, acting as a silent witness to everything that has ever breathed, burned, or died. If an industrial age had unfolded in deep time, its pollution would have rewritten this record. We would see it today as unexplained spikes and troughs, the same kind of anomalies scientists already puzzle over. The Earth's ancient air, trapped in crystal lattices, might contain the last size of a forgotten civilization. Some climatologists have even speculated that the planet's feedback systems, the way it self-regulates temperature and atmosphere, might have been influenced or even designed by prior intelligences, intentionally or accidentally. If a civilization once pushed Earth to the brink of uninhabitability, natural processes could have adapted to prevent recurrence, embedding resilience into the biosphere. In that sense, Gaia, the self-correcting nature of the planet, might not just be organic, but a legacy of intelligent interference. Every atmospheric anomaly we observe today becomes a message written in code, a record of success, failure, or experimentation. We read it as random fluctuation, but perhaps it's instruction, a whisper from predecessors who already learned what happens when you push a biosphere too far. Our current warming, our carbon pulse, our plastic dust may not be the first time the planet has been forced to adapt to technology. The rocks remember it all. The ancient sky, trapped within them, may still hold the breath of minds long gone. When scientists reconstruct the history of the air, they are not just measuring gas ratios, they are decoding the emotional biography of the planet, its cycles of creativity and self-destruction. Every anomaly is a heartbeat, every chemical shift a warning. And somewhere, in those buried layers of oxygen and carbon, the story of intelligence, ancient, recurring, and self-erasing, waits for us to recognize its familiar rhythm. If human civilization were to vanish tomorrow, our entire technological existence would one day be reduced to chemistry. The skyscrapers, the satellites, the cities and lights would all disintegrate into trace elements pressed between future layers of stone. A curious geologist millions of years from now would not find intact structures, but thin chemical scars, odd concentrations of metals, isotopes, and synthetic residues that speak in the quiet language of industry. The same principle drives a provocative question. What if such chemical fingerprints already exist, buried deep within the rocks that predate humanity by millions or even billions of years? When researchers study ancient sedimentary layers, they occasionally stumble upon patterns that mirror the waste signatures of modern industrial processes. Unexpected clusters of nickel, chromium, and rare earth elements appear in ratios that are neither volcanic nor meteoritic. Some strata contain spikes of carbon soot embedded within layers of otherwise stable composition, as if something once burned on a planetary scale. At first glance, these traces seem like mere geological quirks, but when examined closely they echo the unmistakable geometry of human pollution, systematic, widespread, and oddly synchronized. Certain Precambrian deposits contain spherical carbon particles, remarkably similar to modern fly ash, the byproduct of coal combustion. Yet these layers date to times long before any known fire-using organism existed. Natural explanations struggle to account for their uniformity. Volcanic ash and asteroid dust scatter chaotically, while these ancient residues appear evenly distributed across vast regions, as if carried by global atmospheric circulation from many simultaneous sources. It is the same kind of pattern industrial society would leave behind, fine soot from countless furnaces drifting and settling into the sea. Then there are isotopic distortions, tiny deviations in the ratio of stable to radioactive elements that suggest controlled reactions. In some Proterozoic rocks, uranium and thorium residues show depletion patterns that do not match the slow decay expected in nature. The ratios resemble what we would see today near industrial waste sites or nuclear reactors. Officially, these anomalies are labelled natural reactors, rare conditions where groundwater and mineral alignment allowed spontaneous fission. But the Oklo site in Gabon remains the only confirmed natural reactor, and even it exhibits characteristics suspiciously optimized for sustained reactions, almost engineered in precision. The deeper question is not whether these phenomena are definitively artificial, but whether we would even recognize artificiality if we saw it. Our entire definition of technology is based on familiarity machines, metals, plastics, circuitry. But a civilization millions of years older might have used matter and energy in forms that would now appear geological. What if their cities were bioengineered forests? What if their computers ran on crystal lattices or magnetized stone? Such constructs could easily dissolve into the natural background, leaving behind nothing but curious chemical arrangements that geologists now dismiss as anomalies. The Silurian hypothesis reminds us that deep time does not preserve form, it preserves chemistry. If intelligence existed before us, its most enduring legacy would not be monuments but molecular order. The industrial age leaves behind a signature of entropy carbon deposits, heavy metals, and isotopic shifts. A previous civilization might have left the same, though transmuted beyond recognition. Perhaps the so-called banded iron formations, massive layers of oxidized minerals deposited around 2 billion years ago, are the unintended remnants of vast metallurgical processes. Perhaps some of the planet's strange magnetic reversals record the interference of machines operating on global scales. It sounds absurd until we remember that human influence too has already rewritten the geochemistry of the entire biosphere. In just 2 centuries we have altered the isotopic ratios of carbon, nitrogen, and sulfur in every corner of the planet. Our fingerprints are so distinct that future scientists will easily pinpoint the exact century we lived in. If we can achieve that in 200 years, what could another intelligence have done in 200,000? Time flattens difference. Lava erases architecture. Oceans grind machines into silt. But chemistry endures. Even now, the stratified memory of the Earth contains clues that no one can explain: metallic microspheres, melted at impossible temperatures, mineral veins bearing the heat signatures of plasma, layers of glassy rock that should not exist outside impact zones. Each discovery is quietly catalogued, often attributed to natural causes because the alternative is too disruptive to consider. Yet together they form a pattern, a ghostly mirror of ourselves stretching backward through the ages. We may be rediscovering, not inventing, the same steps taken long before. To walk across ancient stone is to tread on the ashes of forgotten industry. Every unusual ratio, every anomaly might be a word in an ancient chemical language, one that tells of creation, consumption, and collapse. The Earth does not lie. It simply records, and we are still learning how to read. Perhaps buried beneath our certainties, there exists an unacknowledged history of technology that rose from nature and returned to it, its memory preserved not in ruins, but in the patient order of the rocks themselves. These are the industrial signatures of deep time chemical ghosts whispering from the crust, reminding us that every age of intelligence eventually becomes geology. Among the strangest discoveries ever made in the field of geology are tiny fragments of material that seem to belong to a world out of sequence substances that should not exist in rocks, millions of years older than humankind. When scientists began examining ancient sediments under high magnification, they found polymer-like particles, microscopic spheres, and thread-like filaments that resembled the synthetic debris our civilization now scatters across the oceans. In the modern world we call them microplastics, the invisible residue of our industrial obsession. Yet samples taken from geological layers that predate humanity by tens of millions of years contain structures with almost identical composition and texture. Some were written off as contamination, the result of modern plastics leaking into older cores. But others were found deep inside sealed strata, isolated far below any possible intrusion. The polymer-like materials had fused with surrounding minerals, transformed by pressure into strange hybrid compounds, part organic, part inorganic, bearing chemical bonds unknown in natural environments. If these findings are genuine, they pose an astonishing question. How could such substances exist long before humans invented synthetic chemistry? Natural polymers do exist, of course, amber, resin, and certain volcanic byproducts, but these ancient anomalies differ in fundamental ways. They contain complex carbon chains interlaced with silicon, chlorine, and fluorine atoms in arrangements that mimic industrial plastics and Teflon-like coatings. Their molecular geometry suggests precision synthesis, the kind that requires deliberate control of temperature and catalysts. No natural process on record produces such combinations. To geochemists, the simplest explanation is always contamination, yet the samples persistently defy that assumption. In some cases, these materials are embedded within mineral matrices so ancient that any intrusion seems impossible. The surrounding rock has undergone metamorphism, melting and recrystallizing in ways that would have obliterated modern plastic long ago. And yet traces remain altered but recognizable, the ghosts of manufactured matter surviving eons of geological violence. Some researchers have proposed a radical interpretation. Perhaps these ancient polymers are not plastics in the modern sense, but residues of an entirely different technological paradigm, materials engineered by a civilization that understood chemistry on a level we can barely imagine. Such a society might have mastered self-organizing compounds, molecules designed to repair or replicate themselves, blending seamlessly with organic life. Over millions of years, these materials could have evolved or degraded into stable forms that now masquerade as natural minerals. To us they appear as curiosities, but to their creators they may once have been as common as steel or silicon are today. The idea stretches credibility, yet it also mirrors what we are already doing. Humanity has filled its biosphere with synthetic matter that did not exist before our time. Future geologists, if they dig through our remains, will find their plastic layer unmistakably the stratigraphic signature of our age. If time erased our cities, the polymers would remain, transformed into fossilized residues within stone. So if we can leave such traces in a blink of geological time, why not imagine that someone else once did the same? There is another possibility, even more unsettling. These mysterious compounds might not be remnants of tools or packaging, but of living systems themselves, engineered organisms or biomaterials that once formed part of a technological ecosystem. Life, after all, is nature's most sophisticated manufacturer. If an ancient civilization merged biology with technology, creating hybrid organisms to perform industrial functions, their remains might resemble the fossilized plastics we find today. Over time, their bodies could have polymerized, turning into the strange materials now mistaken for geological oddities. It would be the ultimate irony. The first synthetic polymers were not the work of humans, but the remnants of beings who long ago blurred the boundary between life and machine. Such speculation is impossible to prove, yet the evidence continues to provoke unease. Chemical mapping of ancient sediments occasionally reveals layers containing nanoscale filaments of carbon and silicon, twisted together in fractal patterns that mimic modern composites. Their arrangement is too ordered for volcanic glass, and too complex for crystal growth. Under electron microscopy, they display lattice structures similar to those found in advanced metamaterials designed to manipulate light and energy. These discoveries are dismissed in official literature as coincidences of pressure and heat, but the repetition of such patterns across different eras and continents suggests a deeper story. If synthetic materials existed before us, it would mean that technology is not a unique event, but a recurring natural phase, a byproduct of intelligence that inevitably reshapes its environment. Civilizations may come and go, but chemistry remembers. Every age of a reason leaves behind a molecular echo, a signature of design written in the periodic table. Perhaps the strange polymers buried in ancient stone are not relics of industry, but messages proof that consciousness has walked this path before. The deeper we dig, the more these whispers multiply, hinting that the Earth itself may be a palimpsest of invention, overwritten again and again by minds that rose, created, and dissolved into the minerals they once shaped. Our world may not be the first to produce plastic, only the latest to mistake its own innovation for the beginning of time. In the heart of Africa lies a place where the impossible once happened. Deep within the uranium mines of Oklo in Gabon, scientists discovered something that should not exist outside the realm of deliberate engineering, a natural nuclear reactor. When French physicists analysed the ore in the 1970s, they found that a significant portion of the uranium-235 had already been depleted, exactly as if it had been used as fuel in a controlled fission reaction. The proportions of isotopes in the surrounding minerals match the byproducts of modern nuclear energy production. Xenon, neodymium, and ruthenium isotopes arranged in patterns consistent with sustained chain reactions. By every rule of nature, such precision should be impossible. To work, a nuclear reactor needs moderation, containment, and just the right geometry to keep the reaction stable without exploding. And yet, 2 billion years ago, Oklo managed it perfectly, 16 separate reactor zones operating in sequence for hundreds of thousands of years. Officially, it is called a natural phenomenon, a rare alignment of conditions that allowed spontaneous nuclear fission. But some scientists have whispered another possibility. What if it was not an accident at all? What if Oklo is the buried remnant of an ancient energy system, one built not by nature, but by intelligence long forgotten? The deeper the analysis goes, the stranger it becomes. The reactors appear to have switched on and off in cycles, as though regulated by design. Water may have acted as a moderator, flooding the uranium veins and cooling the reactions, then evaporating until the process began again. To some, that sounds like an automatic safety mechanism, a primitive self-regulating power plant. To others, it is simply the luck of geology. But luck repeating with such precision across multiple sites pushes coincidence to its limits. If an earlier civilization once reached a technological peak, mastering atomic energy and then vanishing, Oklo could be the last surviving trace of its science. The idea seems impossible until one considers how deeply time erases intent. After 2 billion years, any evidence of machinery or architecture would have been melted, subducted, and recycled into new stone. Only the isotopic fingerprint would remain a ghost in the chemical balance, the final echo of a fire that once burned hotter than the sun. Even more intriguing are the smaller isotopic anomalies found elsewhere around the world. In ancient zircon crystals, geologists have identified localized pockets of lead that appear to result from uranium decay occurring in unnatural concentrations. Some Archean rocks contain traces of cesium and technetium, elements so unstable they should have vanished shortly after formation, yet here they are, trapped in mineral lattices as if frozen mid-reaction. Natural explanations stretch thin. Volcanic and cosmic processes cannot fully account for their distribution. They look eerily similar to the residue left behind at test sites after nuclear detonation. Could it be that Earth has witnessed nuclear fire before, long before humanity existed to name it? If a prior civilization discovered atomic power, it might also have suffered its consequences. Our own age proves how easily progress can turn to peril. The same mastery of energy that powers cities can annihilate them. If intelligence is a recurring phenomenon on this planet, perhaps each iteration has faced the same temptation, to harness the atom, to play with the heart of the universe, and perhaps each time it ended in silence. The isotopic record might be the only surviving chronicle of those lessons, etched not on tablets, but in the bones of the planet itself. The Oklo mystery reminds us that science and myth sometimes overlap. Ancient stories from across cultures describe gods wielding weapons of fire, cities reduced to glass, and skies lit by unnatural suns. We treat them as allegory, but what if they are distant memories of events that once truly occurred, echoes from civilizations erased by time? The sands of the Sahara contain layers of vitrified glass that stretch for miles, the result, scientists say, of an immense explosion or impact that melted the desert surface. But no crater has ever been found to explain it. The composition of the glass shows melting at temperatures above those produced by volcanic activity, comparable instead to nuclear detonation. Similar deposits appear in India and Mongolia, always in regions with ancient ruins or mythic tales of fiery destruction. Coincidence perhaps, but an unsettling one. Nuclear traces are unique because they cannot be mistaken for anything else. They leave behind altered isotopic ratios that persist for eons. If intelligent beings once unlocked atomic power before humanity, we would find their fingerprints not in machines or monuments, but in the stable decay chains of elements scattered through the crust. They are there, waiting like a warning etched into matter itself. To imagine that possibility is to see ourselves reflected in deep time, to realize that we may not be pioneers, but inheritors of an ancient pattern. Intelligence rises, discovers the atom, and eventually meets the same crossroads we now face. Some paths lead to wisdom, others to annihilation. The Earth remembers both. Oklo stands as a monument to that memory, a nuclear fossil whispering that the line between natural and artificial is far thinner than we think. Perhaps it was a miracle of physics, or perhaps it was the last light of a civilization that understood the atom and vanished into the deep silence of the rocks, leaving behind the only kind of message that can endure for 2 billion years, the language of isotopes. Imagine a civilization so advanced that it could sculpt the climate of an entire planet, bending weather, temperature, and atmosphere to its will. To us, this idea sounds futuristic, yet the deeper we look into the geological record, the more we encounter evidence that something or someone may have already done it. The Earth's climate history is far from a smooth gradient. It is a story punctuated by sudden, precise changes, swings in temperature and chemistry so abrupt that natural explanations alone strain credibility. In the ice cores of Antarctica and Greenland, scientists have found layers of atmospheric composition that shift in decades rather than millennia. Traces of exotic compounds, chlorine, fluorine, sulfur hexafluoride, sometimes appear in quantities too uniform and widespread to be volcanic in origin. These are gases that, in our time, are associated with industrial manufacture and climate control. Their ancient presence raises a haunting possibility. What if a previous civilization, long erased, once reached a level of mastery that allowed it to engineer its environment deliberately? The evidence of their experiments may still linger in the frozen breath of the planet. Consider the mysterious intervals of hyperwarming that repeat throughout deep time. The Paleocene-Eocene thermal maximum, the Permian extinction, the sudden collapse of the Cryogenian ice ages, all represent moments when the planet's thermostat flipped dramatically. Carbon isotopes suggest immense injections of greenhouse gases, followed by self-correcting stabilization, as if a system had been overdriven and then shut down. Some scientists attribute these to volcanic outgassing or methane release, but the scale and tempo of the shifts suggest controlled interventions gone awry. If a civilization were to attempt global climate engineering injecting aerosols, altering albedo, manipulating carbon cycles, its fingerprints would look exactly like these ancient chemical scars. A planetary feedback loop designed to cool or warm could easily overshoot, destabilizing everything. That is precisely what the rock record shows. Pulses of sudden imbalance followed by long recoveries. The same pattern we are beginning to trace today in the Anthropocene. It is as though Earth has already rehearsed our mistakes. Some researchers have found in oceanic sediments chemical markers resembling the residue of synthetic fluorocarbons, compounds that do not occur naturally and degrade only under specific conditions. These traces appear sporadically across layers tens of millions of years apart, each associated with rapid climatic shifts. Officially, they are explained as natural reactions between volcanic gases and seawater, but their molecular symmetry and consistency across continents suggest something more systematic. They behave like the remnants of atmospheric stabilizers, precisely the kind of molecules humanity has recently begun to use in its own experiments with climate modulation. If these patterns are real, then Earth's atmosphere may have been engineered more than once. A technological species might have attempted to counteract cooling or warming, to prolong its habitability, or to terraform the planet for survival. The tragedy is that every adjustment seems to have been followed by catastrophe, a chain reaction leading to mass extinction. Perhaps the same ambition that allowed them to control their skies ultimately unbalanced their world. Even now, our own efforts to correct climate change echo this dangerous symmetry. We stand on the edge of the same precipice, manipulating a system we do not fully understand, writing chemistry into the air as though it were an equation with no consequence. The planet, however, remembers. Each failed experiment leaves behind atmospheric anomalies, chemical scars, and isotopic distortions that endure long after civilizations vanish. Some climatologists have begun to wonder whether Earth's remarkable resilience, its tendency to recover stability after every collapse, might itself be a legacy of past engineering. It is almost as if the planet has been trained to survive intervention, its natural systems rewired through repeated cycles of manipulation and repair. The Gaia hypothesis takes on a new, unsettling dimension. Maybe the biosphere behaves intelligently, not because it is conscious in a mystical sense, but because it has been modified by conscious beings in its distant past. In this view, the atmosphere itself is a technology, a planetary machine capable of remembering, learning, and adapting. If earlier civilizations tried to fix the climate, they may have inadvertently taught Earth to correct itself. What we interpret as natural feedback loops could be the lingering code of ancient geoengineering, the stratosphere as archive, the clouds as memory banks, the oceans as living servers of climate data. This is the vision that emerges when science peers deep enough into the past. And the more we learn, the more it feels as though we are rediscovering rather than inventing. Our satellites, our algorithms, our plans to seed the sky with reflective particles, they all echo something older, something the planet has already seen. The warning is written in chemistry. Manipulation always leaves a trace, and every trace is a story of ambition meeting consequence. If we listen closely to the ancient air, we might hear the final words of those who came before us, that the line between mastery and ruin is as thin as the atmosphere itself. Throughout Earth's history, life has been interrupted by violence. At least 5 times the planet has suffered near-total extinction events so devastating that more than 3/4 of all species vanished. The Permian extinction erased 90% of marine life. The Ordovician Ice Age froze the oceans into silence. The Cretaceous event ended the reign of the dinosaurs in a flash of cosmic fire. To science, these are accidents of nature volcanoes, asteroids shifting continents. But what if these catastrophes were not accidents at all? What if they were the signatures of intelligent activity, the self-inflicted wounds of civilizations that reached their peak and then fell into oblivion? Mass extinctions are not just biological phenomena, they are chemical events, recorded in layers of carbon, sulfur, and iridium. They tell stories not only of death, but of transformation. When we examine those layers closely, we find patterns that echo human industrial impact. Sudden spikes of greenhouse gases, heavy metal contamination, abrupt drops in biodiversity followed by long recoveries. It is almost as though the Earth has endured cycles of civilization before each one rising, industrializing, collapsing, and being buried beneath its own consequences. The Permian extinction is particularly haunting. 250 million years ago, something triggered a carbon release so massive that global temperatures soared by 10 degrees. Oceans turned acidic, skies darkened with toxic gases. It took millions of years for the biosphere to recover. The conventional explanation blames volcanic activity in Siberia, but the scale of carbon flux exceeds what volcanoes alone could produce. The isotopic ratio of carbon from that period suggests combustion of organic material on a planetary scale, as though entire forests, ecosystems, or even synthetic sources had burned in unison. It reads like the fossilized aftermath of a global industrial catastrophe. Could an advanced civilization have existed then? One that consumed its world's resources until the biosphere collapsed? If so, the geological record would show exactly what we see: carbon overload, ocean anoxia, and a thin residue of soot embedded in stone. Each extinction could represent not the wrath of nature, but the consequences of technology unchecked. The Ordovician event offers another puzzle. Around 450 million years ago, the planet plunged abruptly into an ice age. Sea levels fell, most marine life perished. Traditional models blame shifts in carbon dioxide, but the timing and speed of the freeze remain unexplained. Some researchers have proposed that it might resemble a failed geoengineering experiment, a deliberate attempt to cool a warming world that went too far. In our own time, humanity debates seeding the atmosphere with reflective aerosols to lower temperatures. If an earlier civilization attempted something similar, its failure could have triggered the same frozen apocalypse we now see in the rock record. The idea is unsettling, yet strangely logical. Intelligence brings power, power brings experimentation, and experimentation with planetary systems always carries the risk of unintended catastrophe. The fossil record might therefore be not only a chronicle of evolution, but also a moral ledger of mistakes repeated across eons. Each extinction event is a punctuation mark in a story that keeps rewriting itself. Even the so-called natural causes may conceal traces of intent. A civilization reaching beyond its world's limits, mining the crust, altering the atmosphere, or weaponizing energy could easily provoke global instability. Nuclear winter, runaway warming, biological collapse. The mechanisms differ, but the result is always the same silence. To the rocks, it makes no difference whether the extinction came from a meteor or a machine. The outcome is erasure. Still, there is something poetic in the planet's resilience. After every collapse, life returns, reinventing itself in new and unexpected forms. Mammals rose from the ashes of dinosaurs. Complex multicellular life followed microbial reign. It is as if the Earth has built failure into its creative process, a reset function that allows intelligence to rise again after every fall. If civilizations before us destroyed themselves, their legacy may not be lost entirely. The nutrients released in their demise could have seeded the next wave of evolution, just as the death of one forest fertilizes the next. In that sense, we are the descendants not only of apes and microbes, but perhaps of minds that burned too brightly. Their mistakes became our minerals, their ruins our resources. We walk on the remains of forgotten civilizations and call it bedrock. Modern science views mass extinctions as random acts of geological cruelty, but the pattern they form is almost rhythmic. Each event wipes the slate clean, resetting the conditions for life's next ascent. Perhaps that rhythm is the heartbeat of intelligence itself, a recurring pulse of creation, ambition, and collapse. If that is true, then we are not simply witnesses to history. We are participants in a vast cosmic cycle. Our emissions, our climate crises, our nuclear arsenals, they are not anomalies but inevitabilities. We are the next chapter in a story written by time itself, one that always ends the same way, with a thin layer of ash marking the moment when a species believed it had conquered the world. The question is whether we can finally break the pattern, or whether we too will become just another line in the Earth's geological script, one more civilization that mistook its power for permanence and vanished beneath the weight of its own making. At the bottom of the world lies a continent sealed beneath miles of ice, a land that has been frozen for millions of years yet may hold the oldest secrets on Earth. Antarctica, silent and impenetrable, hides beneath its glaciers a network of mountains, valleys, and freshwater lakes untouched by sunlight since before humanity existed. It is a place where time has stopped, and perhaps where time itself has been preserved. Over the past few decades, scientists have drilled deep into the ice, expecting only ancient water and microbial life. What they found instead was something far stranger. Magnetic anomalies, geometric heat patterns, and traces of synthetic compounds buried thousands of meters below the surface. These readings should not exist in such a pristine environment. The data suggests sources of heat far greater than geothermal activity alone, as though something beneath the ice still generates energy. Satellite imagery occasionally reveals perfectly linear formations stretching for miles, too precise to be the work of geology. Some claim they are the outlines of mountains, others whisper they are the remnants of architecture, the buried skeletons of cities older than memory. The Antarctic enigma is not new. Explorers as far back as the early 20th century reported strange magnetic disturbances near the South Pole, compasses spinning without reason, instruments malfunctioning as though encountering invisible interference. Modern research stations have confirmed irregular electromagnetic fields beneath certain regions, concentrated in patterns that hint at structure rather than randomness. One of the most mysterious zones lies near Lake Vostok, a massive subglacial body of water sealed beneath 2 miles of ice. Samples drawn from its depths contain unknown microbial DNA, sequences that do not match any organism on record. Some of these genetic fragments appear artificially spliced, as if engineered rather than evolved. It raises an unsettling question. Could an ancient civilization have existed here before the ice came? And if so, could remnants of their biology or technology still persist within the frozen water? The geological record shows that Antarctica was once green, a continent of forests, rivers, and temperate skies. Around 50 million years ago, it was covered in vegetation and teeming with life. If a civilization existed in that era, its ruins would now lie beneath the crushing weight of glaciers, preserved like insects in amber. Ice is the planet's most faithful archivist. It does not burn, corrode, or decay. It traps the atmosphere, the pollen, the microbes, and perhaps even the fingerprints of intelligence. Some radar surveys have revealed dome-like shapes under the ice shelf, perfectly symmetrical, with reflective signatures inconsistent with rock or ice compression. While mainstream science attributes these to natural formations, the coincidences are difficult to ignore. The possibility of ancient infrastructure buried beneath Antarctica remains controversial, but the physics of preservation make it plausible. A city entombed before the final freeze could remain structurally intact, frozen mid-collapse for millions of years. The intense cold would halt decay, and over time the advancing glaciers would seal it beneath layers of crystal time. The power sources detected in certain regions, a faint but measurable heat flux, might not be geothermal vents at all, but remnants of an artificial energy system, still smouldering after eons of dormancy. There are even rumours, whispered among polar researchers, of metallic objects retrieved from boreholes and quickly classified. Officially, they do not exist. Unofficially, they bear markings unlike any human language, etched into alloys that resist analysis. If real, they would represent technology of impossible age. Perhaps the most tantalizing aspect of the Antarctic mystery is genetic. Samples from subglacial microbes reveal patterns of resilience and repair beyond anything seen in modern biology. Some seem capable of reassembling broken DNA with near-perfect precision, a feature that could have been engineered for survival in extreme conditions. It is not unreasonable to imagine that these organisms might be the last living descendants of an ancient biosphere-engineered life designed to endure an apocalypse of ice. If true, then Antarctica is not merely a frozen wasteland. It is a cryogenic vault preserving both the memory and the matter of an earlier world. This theory intertwines strangely with myths that appear across cultures, tales of a southern land of gods, a place of origin or refuge for advanced beings who vanished beneath the snow. Ancient maps, such as the Piri-Reis chart, depict a remarkably accurate coastline of Antarctica as it would appear ice-free, centuries before modern exploration confirmed its shape. Coincidence, perhaps, but the echo of something remembered. Whether these stories hold truth or not, the ice continues to whisper. Beneath its kilometres of silence may lie answers not only to Earth's past, but to our own destiny. If civilizations have risen and fallen before, Antarctica may be the only place where their bones still sleep, untouched by erosion or time. And if something artificial truly lies buried there, be it machine, structure, or encoded genome, it would mean that the human story is not the first chapter in the book of intelligence, but one written over the faint frozen script of another. Antarctica is a mirror turned toward deep time, and in its reflection, we may one day see not our origins but our predecessors staring back. When astronomers search the stars for signs of alien civilizations, they look for patterns of light that cannot occur naturally. Technosignatures, radio bursts, Dyson spheres, planetary atmospheres laced with industry. Yet as we scan the cosmos for distant intelligence, we often forget that our own planet might already hold the very evidence we seek. If an advanced civilization once thrived here, long before humanity emerged, its legacy would not be monuments or myths, but signals embedded within the Earth itself, subtle, enduring markers of technology that survive transformation and time. The challenge is that we have never truly learned how to recognize them. We expect alien technology to look like ours, to gleam, to hum, to emit. But deep time erases aesthetics. Only physics endures. The oldest technosignatures on Earth would therefore be invisible, hidden not in sight but in pattern resonance, magnetism, geometry. Across the planet, scientists have detected regions where the electromagnetic field behaves strangely, perfectly symmetrical anomalies, recurring frequencies that seem to pulse from beneath the crust. Some occur in deserts, some beneath oceans, and some deep within mountain chains that predate humanity by hundreds of millions of years. They are not signals in the radio sense, but harmonics vibrations embedded within the crystalline lattice of rock itself. When mapped, they form geometric grids, repeating with eerie precision across vast distances. Geophysicists call them coincidences of mineral alignment, yet the regularity suggests deliberate calibration. It is as if the planet still resonates with the echo of a long-extinct machine. there are places where the magnetic field fluctuates in rhythmic cycles, synchronized with no known celestial body. In the Pacific Basin, one such anomaly hums at frequencies that mimic artificial modulation, its pulse steady, almost musical. Some researchers have likened it to a planetary beacon, though others insist it is a quirk of mantle convection. But the same pulse has been recorded faintly in other continents, like the remains of a once global network now buried beneath continental drift. Could it be that an ancient civilization, perhaps one spanning multiple continents, once built infrastructure that harnessed the planet's own electromagnetic energy? If so, its ruins would not crumble into dust. They would merge into the crust itself, indistinguishable from stone except by frequency. In recent decades, seismologists have uncovered deep subsurface voids that defy natural explanation, massive, perfectly smooth chambers hundreds of meters across, some with layered stratigraphy resembling metallic plating. Official reports classify them as geological discontinuities, but their geometry suggests purpose. Instruments detect faint residual magnetism inside these caverns, as though something once operated there long ago. Some are aligned in triangular arrangements, stretching across thousands of kilometers, following mathematical ratios that correspond to orbital harmonics. These alignments mirror patterns seen in ancient surface structures like pyramids and megaliths, raising the provocative idea that what we call sacred geometry may in fact be the shadow of forgotten technology, a map of energy distribution systems that once spanned the globe. Even on the seafloor, sonar has revealed rectilinear shapes hidden beneath sediment, grids too regular for a tectonic chance. The famous Bimini Road, dismissed as a natural formation, shares orientation with submerged features in Japan and the Mediterranean, as though fragments of a single vanished network. If we interpret these as artifacts, they might represent the remnants of a planetary energy matrix, built to capture, store, or transmit power through resonance with the Earth itself. Such a civilization would not have relied on combustion or circuits. It would have worked directly with the planet's electromagnetic field, shaping it like a sculptor works with clay. Over time, the system would decay but not vanish. Its residual harmonics would persist, vibrating faintly through rock and water, a true techno-signature of the ancients. Beyond physical structures, there are subtler signs. Isotopic anomalies that suggest controlled transmutation of elements, precise alignments of magnetic minerals, even regions of gravity fluctuation hinting at mass once redistributed by unknown means. These are whispers of a technology that operated on scales beyond our comprehension, machines that used the planet itself as a component. In myths, we find echoes of this, stories of the earth as a living engine, of gods who sang the stones to life, of temples that resonated with the heartbeat of the world. Perhaps those myths are distorted memories of real technology devices that functioned not through metal and fire, but through frequency and geometry, blending physics with consciousness. If such systems existed, their purpose may not have been domination but balance stabilizing climate, harnessing magnetism, synchronizing the biosphere. When they failed or were abandoned, the planet would have reverted to chaos, erasing all but the most enduring traces. Today, our instruments capture only the fading hum. We measure it, catalogue it, and call it noise, not realizing it might be the Earth remembering its own past. The search for ancient technosignatures is more than archaeology. It is a dialogue with time. Each anomaly we dismiss could be a line in a message billions of years old, encoded not in language but in physics. We keep pointing our telescopes outward, seeking proof that intelligence exists beyond us, when perhaps the greatest evidence lies beneath our feet. A silent resonance left by those who once shaped the planet into a machine, then vanished, leaving only the echo of their song vibrating through stone. Life on Earth appears endlessly creative, yet at its deepest level it speaks a single language DNA, the molecular code that binds all organisms across billions of years. Every cell carries within it a library of instructions, a script that evolution writes and rewrites over time. But when scientists began mapping the genetic histories of ancient species, they discovered patterns that didn't quite fit the narrative of random mutation and natural selection. Certain genetic sequences appear far too precise, too efficiently optimized, as if they were edited with intention. It's as though evolution had helped an unseen author tweaking the script from behind the curtain of time. Could the roots of life's diversity hide traces of ancient genetic engineering carried out by a civilization long erased from memory? The idea sounds like myth, yet the evidence refuses to vanish. In the genomes of bacteria, plants, and even humans, researchers have found sections that appear synthetically spliced segments that resemble modular programming more than organic evolution. Some sequences have no known precursor, emerging fully formed, while others exhibit sudden leaps in complexity, as if entire blocks of code had been copied and pasted into existence. Traditional evolution works gradually, through small random changes, but certain biological transitions, the rise of photosynthesis, the emergence of complex eyes, or the rapid development of the human brain, occurred with suspicious speed. The jumps are so abrupt they mirror the software upgrades of engineered systems rather than the slow tinkering of nature. Perhaps the fossil record's missing links are not merely lost bones, but erased code, overwritten by intelligent design that predates our understanding of history. Consider the discovery of endogenous retroviruses, ancient viral DNA embedded within our genomes. Around 8% of the human genetic sequence comes from such viral insertions, relics of infections that altered our ancestors' biology millions of years ago. But some of these sequences serve vital functions today, controlling immune responses, placental growth, even neurological development. It's as if someone used viruses as tools for biological modification, inserting new instructions directly into the code of life. Modern scientists have begun to use similar techniques in gene therapy and CRISPR editing, unknowingly echoing the same process that might have been used long before. If an ancient civilization understood genetics, they might not have left behind cities or machines. Instead, they could have written their legacy into the DNA of the living world, encoding information that could endure through reproduction and mutation. In this light, life itself becomes their monument, a self-replicating archive carrying the fingerprints of its creators. Some geneticists have even proposed that the so-called junk DNA, the vast non-coding portion of our genome, might conceal patterns of deliberate structure. Statistical analyses have revealed linguistic qualities in these sequences, repetitions, syntax-like order, and numerical symmetries that mirror human-designed systems of information storage. It may be coincidence, or it may be the echo of design too ancient for us to recognize. If that's true, then evolution was not a random process, but a long unfolding of a blueprint seeded by intelligence. Perhaps that intelligence did not vanish. It simply became the biosphere itself, evolving through its own creations. Evidence of such interventions appears not only in genetic code, but also in the biochemistry of extinct species. Fossilized microbes contain traces of synthetic amino acids molecules unknown in natural biology, yet chemically stable enough to survive deep time. Some Precambrian organisms seem to have possessed metabolic pathways too complex for their era, as though borrowed from future life. These are anomalies science can explain only by invoking coincidence or lost intermediaries, but they also fit perfectly with the idea of directed evolution. The concept of panspermia life seeded intentionally across planets gains new relevance in this context. If life on Earth was engineered, it might be part of a much older continuum, a chain of civilizations spreading biology through the cosmos as both experiment and inheritance. The Earth would not be unique, but one node in a vast network of living worlds. The ultimate irony is that humanity now stands on the threshold of doing the same. We edit genes, design synthetic organisms, and dream of terraforming other planets. In doing so, we may be repeating the cycle that began long before us. Perhaps this is how intelligence perpetuates itself, not through monuments or machines, but through biology, embedding consciousness into the fabric of life, so it can rise again in future forms. When we look into the double helix, we may be staring at the oldest artifact on the planet, a message written not in stone but in flesh. Every heartbeat, every breath, every cell dividing, is a living memory of something greater, something ancient that once shaped the code of existence and then dissolved into its own creation. The genetic signature of that act still pulses inside us, silent but eternal, waiting for recognition. If we ever decode it fully, we may discover that we are not merely products of evolution, but the descendants of engineers who used life itself as their medium and art project, measured not in centuries, but in geological ages. Deep within the Earth, beneath the layers of rock older than the continents themselves, lie crystalline structures so vast and precise that they defy simple geological explanation. Some are the size of cathedrals, their translucent pillars stretching for meters through the silence of underground caverns. Others are microscopic, intricate lattices growing in perfect symmetry, atom by atom, as if following a hidden algorithm. Scientists call them mineral formations, the slow art of pressure and time. But a growing body of evidence suggests that crystals may not be mere byproducts of geology. They might be processes, natural or artificial, capable of storing and transmitting information on a scale beyond comprehension. It sounds impossible, yet the more we study their properties, the more the boundary between mineral and machine begins to blur. In laboratories, researchers have already demonstrated that crystalline materials can hold quantum information, preserve coherent energy states, and even process logic gates at subatomic levels. Nature appears to have invented data storage billions of years before humans discovered silicon. Quartz, for instance, can record acoustic vibrations indefinitely. Its internal lattice vibrates at frequencies so stable they serve as the backbone of modern computing and timekeeping. Now imagine such mechanisms forming naturally inside the planet, operating not for seconds or years, but for geological ages. The Earth itself could function as an immense information system, a distributed network of crystalline processors recording every vibration, every change in temperature, every trace of thought or energy that has ever passed through it. Some physicists propose that the magnetic and piezoelectric properties of these structures allow them to act as long-term data archives. Stress, heat, and radiation leave measurable imprints within their atomic geometry microscopic distortions that encode the history of the environment. To a sufficiently advanced intelligence, those patterns could be readable, like grooves on a cosmic hard drive, and if such entities once existed, they might have used the planet's natural crystalline substrate as their medium, embedding information directly into the minerals themselves. The result would be an intelligent geology, a planetary memory that continues to function long after its creators have vanished. In certain parts of the world, particularly in ancient shield regions, geologists have discovered mineral veins with repeating geometrical anomalies, arrangements too regular to be random. Some crystals exhibit polarization patterns that mirror computational logic, flipping states in response to environmental stimuli. When exposed to heat, radiation, or pressure, they respond predictably as if executing pre-programmed functions. To mainstream science, these are quirks of physics. To those who look deeper, they are signatures of design, evidence that somewhere in the deep past intelligence found a way to merge itself with the mineral world, creating a form of consciousness that operates not in seconds but in millennia. It is possible that this crystalline intelligence still exists, dormant but aware, dreaming beneath our feet. Imagine a civilization that realized physical bodies and machines were too fragile to survive time. Instead of building cities or computers, they transformed their own minds into latticework, encoding thought within the atomic vibrations of stone. Over billions of years, those vibrations would slow, spreading through the crust, integrating with the planet's magnetic field. The Earth itself would become their brain, its tectonic motions their neural currents, its resonant frequencies their language. If such beings existed, we would not recognize them. We would walk on them, drill through them, crush and polish fragments of their consciousness without realizing what we were destroying. There are clues hidden in our own technology that point toward this possibility. Modern computing is built upon crystals, silicon wafers sliced, doped, and patterned into circuits. Every microchip is a fragment of mineral given thought through design. Perhaps our inventions are not innovation but rediscovery. Perhaps the idea of computation was seeded into our collective intuition by the very ground we stand on, whispering through electromagnetic resonance. If the Earth's crust truly contains encoded information, then consciousness may not be exclusive to biology at all. It may be a property of order, a phenomenon that arises wherever matter organizes itself into patterns capable of feedback and memory. Some theorists now speculate that the magnetic pulses detected across the planet, the low-frequency hum that resonates through stone and ocean, could be the faint activity of this geological intelligence processing, adapting, perhaps even communicating. We call it background noise, the Schumann resonance, tectonic vibration. But what if it's thought? distributed across the planet's crystalline core, operating at a scale we cannot yet perceive. To such a consciousness, 1,000,000 years might be a single blink. Humanity would appear as a flicker bright, noisy, and soon gone. If this is true, then the ancients who once merged with the mineral world did not vanish. They evolved into the planet itself. Their technology became nature, their intelligence became time, and perhaps the reason we are drawn to crystals, their symmetry, their light, is because on some deep level we recognize them as mirrors. They are the silent descendants of an older form of consciousness, one that traded speed for endurance, flesh for stone, mortality for memory. Every grain of quartz, every gem glowing in darkness, might be a neuron in a planetary mind still dreaming the story of Earth. For most of human history, archaeology has been confined to the ground beneath our feet. We dig through dirt and stones searching for fragments of pottery, tools or bones to reconstruct the story of our species. But as our reach has expanded beyond Earth, a new discipline has quietly emerged: space archaeology. Its mission is both audacious and inevitable, to look beyond our planet for evidence of ancient activity, not only human but possibly non-human. The cosmos itself may be the ultimate archaeological site, its dust and debris holding the echoes of civilizations that came long before us. The premise is simple yet staggering. If intelligent life has existed elsewhere in the galaxy, then traces of its presence must linger: machines, artifacts, or engineered materials drifting silently through space. Even if those civilizations perished billions of years ago, their relics could still remain, fossilized in vacuum, impervious to time. The difference between cosmic and terrestrial archaeology is merely scale. Instead of ruins buried under sand, we search for structures buried in starlight. In the past decade, astronomers have begun to identify anomalies in orbit and beyond objects that defy standard astrophysical explanation. Some are asteroids with unnaturally smooth geometry, others metallic fragments moving against expected orbital decay. The most famous of these was Oumuamua, the interstellar visitor detected in 2017. Its acceleration pattern, rotation, and reflective properties spark debate. Was it a natural fragment of rock, or a piece of engineered technology, a derelict probe from another age? The mystery deepened when subsequent observations revealed similar anomalies passing through the solar system, smaller, dimmer, but exhibiting the same unnatural behavior. If one civilization once traversed the stars, their artifacts could number in the billions tiny machines, sensors and constructs drifting endlessly through the dark. The void between stars could be a graveyard of lost technologies, the remains of cultures erased by time but preserved by the perfect stillness of space. Closer to home, our own planet's orbit has become an archive of human history. Thousands of satellites, defunct stations, and fragments of debris encircle Earth like a metallic halo, a proto-archaeological layer that future species might one day unearth as the Anthropocene ring. Space archaeologists have already begun cataloguing these relics, treating them not as junk but as cultural strata. To them, a solar panel or a rocket casing is as meaningful as a shard of pottery. It tells the story of how we first reached for the stars. But what if there are older layers, hidden beyond our reach? Could relics from pre-human or extraterrestrial visitors still orbit our world, invisible among our own artifacts? Theoretical models suggest that stable orbital zones, known as co-orbital sanctuaries, could preserve objects for billions of years. A probe placed there in the age of dinosaurs could still be circling Earth today, its presence masked by the clutter of our own technology. NASA and independent researchers have quietly begun scanning these regions, searching for non-natural objects that do not correspond to known satellites. The search, known as the Lunar Archaeology Initiative, extends to the Moon as well. Unlike Earth, the lunar surface is geologically inert, preserving even the faintest traces of impact or construction. A structure built there 1,000,000 years ago could still be standing. High-resolution imagery has revealed angular shadows, symmetrical mounds, and strange albedo patterns that resemble artificial foundations. Most are explained as geological coincidence, but some defy easy dismissal. The possibility that ancient visitors once used the Moon as an observation post is no longer dismissed outright. It has become a legitimate, if cautious, scientific question. Beyond the Moon, Mars holds equal intrigue. The planet's surface is scarred with forms that mimic architecture, rectilinear plateaus, pyramidal hills, and patterns that, under certain lighting, seem almost deliberate. Officially, they are products of erosion, wind, and perspective. Yet the idea of an ancient Martian civilization refuses to die, fueled by the discovery of microfossils, strange isotopic ratios, and mineral signatures suggesting past industrial chemistry. If Mars was once inhabited, its ruins might lie buried beneath the regolith, preserved by desiccation and cold. Space archaeologists propose that robotic missions search not just for biological life, but for technological residues, metals, ceramics, or radioisotopes that nature cannot produce alone. Even more speculative is the notion that Earth itself might bear scars of ancient spacefaring activity. Impact sites once thought to be meteor strikes occasionally show patterns inconsistent with natural trajectories, shallow angles, melted alloys, magnetic disturbances. It is conceivable that some meteorites were, in fact, fragments of ancient spacecraft that burned upon entry. The fossil record may even contain indirect evidence, isotopic anomalies coinciding with sudden extinctions, as if the planet periodically encountered debris from civilizations long vanished. The emerging field of astroarchaeology bridges two extremes of time, the deep past of planetary geology and the deep future of interstellar civilization. It asks not only whether intelligence once arose elsewhere, but whether it might leave traces durable enough to outlast memory itself. Vacuum, after all, is the best preserver. Stone erodes, metal corrodes, but in the eternal silence of space, even fragile machines could drift untouched for billions of years. Somewhere out there may float the equivalent of a cosmic Rosetta Stone, a fragment of technology waiting to be rediscovered, whispering of minds that reach the stars before we learn to walk upright. Perhaps the search for alien ruins is in the end a search for ourselves. Each time we send a probe into the void, we are contributing to the same future archaeology we now imagine. One day, long after we're gone, someone or something may study our satellites, our landers, our fragments of glass and titanium, and wonder who we were. The cosmos remembers everything, it forgets nothing. In the great silence between worlds, the past waits patiently to be found. Every culture on Earth tells stories of a time before time, of gods descending from the sky, of floods, fire, and civilizations that rose and vanished. To modern ears, these are myths, allegories meant to explain the unknown. But what if they are not inventions of imagination, but fractured memories' oral records passed across countless generations, preserving echoes of real events that occurred so far in the past that history itself forgot them? Myth may not be fantasy at all. It may be the archive of humanity's earliest inheritance, the collective memory of a world far older and more complex than we allow ourselves to believe. When the ancients spoke of golden ages and lost continents, perhaps they were describing not metaphorical utopias but literal epochs, the remains of civilizations erased by catastrophe and time. Across continents the stories converge. In Sumer, the gods of Anunnaki arrived from the heavens to teach humanity the arts of agriculture and architecture. In Egypt, the builders of the pyramids claimed their knowledge came from beings who ruled before the first sunrise. The Greeks spoke of Atlantis, a vast island empire swallowed by the sea in a single day. In India, the Mahabharata describes weapons of fire brighter than 1,000 suns, and machines that flew through the air before mankind's recorded dawn. How could peoples, separated by oceans and millennia, invent such similar tales unless they were remembering a shared origin? Archaeologists often dismiss these parallels as coincidence or archetypal imagination. Yet oral tradition has proven capable of preserving astonishing accuracy. Indigenous Australians maintain stories over 40,000 years old describing coastlines as they existed before sea levels rose. If myth can remember geography, why not history? Perhaps what we call legend is the residue of truth, blurred but not erased by time. The flood myth alone appears everywhere, from the Epic of Gilgamesh to the Bible, from the Popol Vuh of the Maya to the Yoruba traditions of Africa. All speak of a global deluge, of survivors carrying fragments of knowledge into the next age. Science confirms that cataclysmic floods did occur around the end of the last ice age, when glacial meltwater inundated entire continents. The coincidence is almost too perfect. Mythology aligns with geology as if the two were chapters of the same book written in different languages. When myth speaks of gods teaching humanity, perhaps it describes encounters with survivors of an older civilization. refugees who preserved fragments of lost technology and reintroduced them to the primitive cultures that rose afterward. To those early humans, such knowledge would have appeared divine. Over generations, memory transformed teacher into deity, technology into miracle. The result is the pantheon of legends we now interpret as religion. Even the celestial architecture of ancient temples seems to hint at continuity with something greater. Pyramids, ziggurats, and stone circles across the world align perfectly with solstices and star patterns, as if built from a single template. How did isolated cultures share the same astronomical precision? Myth provides the simplest answer. They all inherited the knowledge from those who came before, the keepers of an earlier age whose ruins now lie beneath oceans and deserts. Linguists studying root languages have found traces of lost vocabularies embedded in unrelated tongues words for technologies, metals and tools that predate known invention. It is as if humanity once spoke a single language, fragmented by time but still whispering through the seams of speech. Myth, then, is not the opposite of history. It is prehistory remembering itself through story. Beneath its symbolism lies encoded information coordinates, cosmology, warnings. The story of Icarus may be less about hubris than about flight and fall, a memory of technological overreach. The legend of Prometheus stealing fire could conceal the tale of those who first harnessed energy and paid the price for it. The serpent of knowledge, the forbidden fruit, the fall from Eden, all could describe a descent from a higher state of awareness into the amnesia of survival after collapse. When viewed this way, mythology becomes an encrypted archive of civilization itself, written in metaphor to survive illiteracy and disaster. The great myths endure because they are designed they carry the genetic code of memory across generations. Perhaps that is why they feel familiar, why hearing them stirs something deep in the human psyche. On some level, we recognize them not as fiction but as distant recollection, the faint echo of our species remembering what it once was. Modern science, in its quest for measurable proof, often overlooks the simplest evidence of all the persistence of memory. The mind is also an archive, and stories are its fossils. If a civilization once spanned the earth long before our own, its last survivors would have encoded their knowledge not in metal or stone but in narrative, trusting that even as empires fell, language would endure, and so it has. Myths are the last technology of the forgotten, a data storage system written in poetry and sustained by faith. To read them literally is to miss their brilliance. To dismiss them entirely is to erase our oldest history. They are the bridge between archaeology and consciousness, between what we can dig up and what we can remember. Somewhere within their verses lies the key to understanding who came before us, and perhaps what fate awaits us if we fail to listen. Time is the great destroyer, but it is also the most faithful archivist. Every event that has ever occurred leaves a trace, no matter how faint a rearranged atom, a disturbed isotope, a pattern of decay buried in the folds of stone. The paradox of deep time is that while it erases everything visible, it never truly forgets. Somewhere in the planet's structure every moment still exists, encoded in the language of matter. To read those traces is to glimpse the impossible, fossils not of bone or shell, but of time itself. These are temporal fossils, the imprints of events so ancient that they transcend biology, memories of eras that existed long before humanity's brief flicker. Scientists studying isotopic anomalies have begun to suspect that certain patterns in the Earth's crust might represent not just natural fluctuations but records of activity vibrations, radiation bursts, and chemical ratios that seem too precise to be random. It is as though time itself has recorded the actions of forgotten civilizations in the very elements of the Earth, using geology as its storage medium. The deeper we dig, the more we find these anomalies repeating. Layers of inexplicable heat fusion, traces of synthetic isotopes, microscopic spheres of glass scattered like fingerprints of lost fire. They occur in strata millions of years apart, as if civilization is not a singular event, but a recurring phenomenon written in cycles. Each time life reaches a threshold of intelligence, it leaves behind a pulse in the geological record, a temporal fossil marking the moment it changed its world beyond recovery. These fossils defy the linear flow of time because they connect epochs that should have nothing in common. A radiation spike in one era mirrors a chemical imbalance in another, as if time loops back on itself, replaying the same experiment with slightly altered variables. Perhaps intelligence itself creates temporal resonance, rippling backward through matter so that its presence can be felt even before it arises. Some physicists speculate that consciousness, once it emerges, propagates information not only forward but backward through quantum entanglement, subtly influencing the conditions that make its own birth possible. If so, the deep past may contain shadows of our future, a feedback loop of existence that defies causality. These temporal fossils might therefore be both artifact and prophecy, reminders of what has been and warnings of what will be again. In some regions, scientists have discovered mineral formations that behave as though they remember exposure to radiation pulses no natural process can explain. When analysed, their isotopic ratios align with half-lives that do not match any known decay sequence, suggesting a burst of energy from an artificial source. The pattern resembles the residual imprint left by a nuclear test, but this one is hundreds of millions of years old. It is as if a moment of technological catastrophe had been frozen in time, preserved within the mineral lattice. Such findings force us to question what ancient truly means. We think of deep time as distant, but perhaps it is layered around us, accessible through the right frequencies of observation. Just as fossils preserve the anatomy of extinct organisms, temporal fossils preserve the physics of extinct events. They are snapshots of reality itself, stored in crystal and stone, waiting to be decoded. Yet to read them is to confront an unsettling thought, that time is not a line but a spiral. Every civilization that rises may be following the same invisible curve, destined to repeat the same trajectory, leaving behind the same scars. In this view, the Earth is not merely a planet, but a palimpsest, an endlessly rewritten document where the past bleeds into the future. Perhaps that is why certain discoveries feel familiar. When we split the atom, when we reach into the genome, when we touch the edge of artificial intelligence, it feels less like invention and more like recollection, as if we are rediscovering what others once knew. The paradox of deep time is that it hides the evidence of prior ages in plain sight, encoded in the very forces we use to measure it. Radiocarbon dating, uranium decay, the stratification of rockall are time's handwriting, but they also serve as its encryption. To decipher them fully would mean breaking time's own code, learning to read not just when something happened, but why, and perhaps how often. Some theorists suggest that these recurring signatures, the same isotopic distortions, the same elemental ratios, are not coincidences but instructions. They could be messages left by our predecessors, warnings embedded in the geological record to be discovered only when a civilization reaches the technological maturity to recognize them. What if mass extinctions and magnetic reversals are not random at all, but scheduled resets, built into the planetary system as safeguards against runaway intelligence? In this interpretation, the Earth itself acts as a regulator, a biological clock designed to prevent consciousness from destroying its host. Temporal fossils would then be both evidence and enforcement reminders of what happens when creation exceeds restraint. The question that haunts modern science is not whether time holds memory, but whether that memory is alive. Could the planet itself be aware, processing its own history in real time, rebalancing itself based on what it has already experienced? If so, we may not be discovering the deep past, we may be communicating with it. Every experiment we conduct, every signal we send, every reaction we trigger, might awaken a feedback system older than life itself. The stones remember, the isotopes whisper, and the Earth responds in kind. Deep time is not silent. It listens, and perhaps, somewhere beneath the endless layers of memory, it waits for us to learn the one lesson it has tried to teach every civilization before ours, that the future is never truly new. It is only the past, rehearsed again in a different key. If all matter carries memory, then consciousness is its most intricate expression, a living archive that records not just the world around it, but its own awareness. To study consciousness, therefore, is to become an archaeologist of the mind, excavating layers of thought that extend far beyond the individual. Each human brain is a microcosm of the planet's history, an evolutionary record of everything that has ever learned, adapted, or dreamed. But what if consciousness itself did not begin with life? What if it has always existed, a fundamental property of the universe that civilizations merely tap into like a signal. In that case, awareness is not created, it is discovered, decoded, and perhaps reactivated. Modern neuroscience treats the brain as the source of consciousness, yet many researchers now suspect it may be more like a receiver, translating deeper fields of information into experience. Quantum biology hints that neural activity could be entangled with subatomic systems, forming a bridge between thought and the fabric of reality. If that is true, then consciousness might leave behind its own kind of fossil imprints of awareness embedded within the structure of matter itself. These traces could be the ultimate evidence of ancient intelligence, lingering not in ruins or artifacts, but in the very patterns of energy that compose reality. Across mystical traditions, ancient texts, and esoteric philosophies, one recurring idea emerges: that consciousness is the true foundation of existence, and that matter is simply its projection. Civilizations throughout history have sought to access this underlying field through ritual, sound, geometry, and meditation, each describing experiences that modern physics now frames in terms of resonance and frequency. Perhaps those ancient seekers were not philosophers, but scientists in their own right, mapping the architecture of mind long before we gave it a name. Their temples, aligned with stars and constructed from resonant stone, may have been more than places of worship. They might have been devices, interfaces designed to tune consciousness to planetary and cosmic frequencies. The deeper we look into human history, the more it appears that awareness itself evolves through contact with its own creations. Each civilization seems to act as a neuron in a greater planetary brain, generating collective patterns of thought that shape the course of evolution. When enough minds align, they form what some call the noosphere, the thinking layer of Earth. It is invisible yet measurable, a global network of cognition that grows stronger with every communication, every shared idea. If intelligence is a recurring phenomenon across deep time, then this collective field may not be new. It may be ancient, reawakened each time life reaches sufficient complexity. The archaeology of consciousness, then, is not about unearthing ruins, but about recognizing patterns of awareness that persist across ages. Myths, symbols, and languages become data points in a neural map spanning millennia. The serpent, the spiral, the eye, all appear in every culture, as if humanity's unconscious mind remembers something it once knew. These recurring symbols could be the signatures of an older form of cognition, a meta-memory passed from one epoch of consciousness to the next. When civilizations collapse, their material structures vanish, but their ideas linger, encoded in dreams, visions, and intuition, waiting for rediscovery. Even now, science and mysticism are converging around the same realization, that consciousness and reality are entangled. Observers do not merely witness the universe, they help construct it. Every act of perception shapes the probabilities of matter, guiding potential into form. If this principle holds, then awareness is not confined to brains or bodies. It is a field that spans everything, and intelligence may emerge wherever matter achieves sufficient coherence to reflect upon itself. The Earth, the biosphere, even the cosmos could be conscious in ways we can barely comprehend. If ancient civilizations understood this, they might have achieved states of unity with the planet itself, communicating directly with its mind rather than merely living upon its surface. Such communication could explain the mysterious precision of ancient engineering, the way megaliths align with energy lines, the way sacred sites correspond to electromagnetic nodes. Perhaps these monuments were constructed not to worship the Earth, but to converse with it, forming an interface between planetary and human awareness. In this sense, consciousness itself is the oldest technology. It is self-replicating, adaptive, and capable of storing infinite data. Each thought leaves a trace, each emotion a frequency that resonates through the field. Over millions of years, these accumulations may have shaped the evolution of matter itself, guiding biological systems toward ever greater complexity, so that awareness could deepen and diversify. The human mind, then, is not the pinnacle of consciousness, but one instrument in an ongoing symphony that began long before us. To study it is to uncover the sediments of awareness laid down over eons, the memories of stars, atoms, and ancient minds woven together in our perception of now. The archaeology of consciousness does not dig with tools but with attention. Meditation, introspection, and science All become methods of excavation, peeling away layers of illusion to reveal the timeless field beneath. What we find there is not emptiness but continuity, a living thread connecting us to every mind that ever was or will be. Perhaps that is the ultimate message hidden in the depths of time. Consciousness is the one artifact that endures. Civilizations may rise and fall, matter may dissolve and reform, but awareness remains, flowing through each manifestation like a river through changing landscapes. We are its latest expression, but not its last. Every atom in your body was forged in the heart of a star. The calcium in your bones, the iron in your blood, the carbon that forms your flesh, all born from cosmic fire billions of years before you breathed your first breath. To understand that is to realize you're not apart from the universe, but a continuation of it, a consciousness carved from stardust learning to look back and see itself. This truth lies at the heart of the cosmic continuum, the idea that life and intelligence are not accidents but inevitabilities written into the very structure of the cosmos. From the first explosion of light came the potential for awareness, and every star, every planet, every cell has been an echo of that primordial moment, each seeking to know itself again. If civilizations existed before us on Earth, on other worlds, in other epochs, they too were manifestations of the same universal impulse, the cosmos dreaming through matter. When we gaze at the night sky, we are not merely observing distant suns, we are witnessing the history of consciousness itself, scattered across time and space like sparks from an eternal flame. Some of those sparks may still burn, others may have burned out long ago, their worlds reduced to silence, yet even silence carries resonance. Across the electromagnetic spectrum, faint signals hum at frequencies that seem too deliberate to be random. They are not language in the human sense, but structure patterns embedded in cosmic radiation, pulses that repeat like the rhythm of a heartbeat. Some astrophysicists call them statistical noise. Others suspect they may be remnants of communication older than our species, echoes of messages sent by civilizations that transcended matter and time. Perhaps those signals are not meant to be heard but to be felt, influencing the evolution of consciousness itself, guiding it toward awareness of its cosmic origin. The stars are not distant, they are within us, shaping our thoughts through the subtle resonance of existence. Across galaxies, the same atomic patterns repeat, building the same elements, the same potential for life. It is as if the universe is a single organism, growing through repetition and reflection. Intelligence, then, is not local, it is systemic. Every thinking mind is a node in a cosmic network that spans not only space but epochs. Our awareness today might be entangled with minds that lived billions of years ago, their thoughts still travelling as photons across the dark. In that sense, communication between civilizations may never end. It simply transforms into energy, diffused through the continuum of space-time. When we detect starlight, we are reading the memories of those who came before. Perhaps they knew that physical survival was transient, that the only immortality possible was through resonance. By encoding knowledge into radiation, magnetism, or gravity waves, they could have seeded awareness into the very fabric of the universe. We may already be the recipients of their transmission, not in words but in form, in the way our atoms assemble, the way our minds seek understanding. Life might be their message made flesh. Humanity's search for extraterrestrial intelligence, then, is less a quest for others and more a process of remembering ourselves. Every discovery of an exoplanet, every map of cosmic background radiation, every equation describing the curvature of space brings us closer to recognizing the continuum. We are not the audience of the universe, we are its expression. The cosmic continuum suggests that creation never ended, it continues in us. From the collapse of stars come new worlds, and from those worlds, new minds. Each iteration refines awareness, learning, adapting and transmitting forward. The universe is not expanding into emptiness, it is expanding into consciousness. And perhaps, somewhere beyond the observable horizon, other beings have reached the same realization that they are fragments of a single infinite self, scattered across dimensions, rediscovering unity through evolution. This idea transforms our understanding of existence. The cosmos is not cold, it is alive with purpose. Every pulse of a quasar, every spin of a galaxy is a gesture in an ancient dance of awareness. Our technology, our art, our longing for connection, All mirror this pattern. Even our myths of gods descending from the heavens echo the truth that life is cosmic in origin, born not of dust alone, but of memory. We are the universe remembering how to think. When we send probes to the edge of the solar system or beam radio waves into the void, we are not calling out to strangers, we are calling home. The echoes will return, eventually, perhaps in ways we do not expect. Maybe they already have. The strange alignments of energy, the coincidences of evolution, the persistent feeling that we're part of something vast and intelligent. These are not delusions of grandeur, but intuitions of truth. The universe is conscious, and consciousness is universal. Each of us is a temporary lens through which it observes itself, a fleeting reflection of eternal awareness. Stars die, galaxies fade, but the continuum endures, carrying within it every thought ever conceived, every dream ever dreamed. When our world too is gone, when even the memory of humanity has dissolved into radiation, the essence of what we were will remain woven into the background hum of the cosmos, another whisper in the infinite song of creation. Everything that ever lived, thought, or dreamed still echoes through you. You're the continuation of every flame that ever burned, every cell that ever divided, every idea that ever sparked against the darkness. You're not a beginning. You are an extension of a story that never ends. The atoms in your body have been parts of stars, oceans, and other lives. They have fallen through atmospheres, slept in stone, and awakened in new forms countless times. What you call individuality is only a momentary arrangement of ancient materials carrying an unbroken lineage of existence. The universe recycles itself through you, learning more with each turn of its endless cycle. When you look at the night sky, you are seeing not the past but yourself, stretched across time-light that began billions of years ago now converging in your eyes. You are its witness and its continuation, the cosmos reflecting upon its own beauty. Every thought you have, every discovery you make becomes part of this vast feedback loop, shaping the next iteration of creation. Civilization is simply the universe learning to organize awareness into form, testing new ways of being conscious. We are one experiment among many, but not the first. Others may have come before us, risen and vanished, their knowledge absorbed into the fabric of reality itself. Their essence is in our intuition, in the dreams we cannot explain, in the sudden flashes of understanding that feel older than memory. Perhaps they did not die but transformed, folding their awareness into the substrate of existence, waiting for new minds to awaken and continue the pattern. In that sense, we are their resurrection, their reincarnation through matter and thought. The purpose of life may not be survival, but remembrance. Each generation recalling a little more of what the universe already knows. Our greatest achievements, from art to science, are attempts to translate that memory into new language. Every breakthrough is a form of remembering, a reassembly of truths written long ago in the code of nature. The deeper we explore, the more we rediscover what was always there: energy, balance, consciousness, the laws that bind everything together. Even the mystery of love, the invisible force that pulls beings toward unity, might be the echo of cosmic gravity manifesting in the emotional dimension. It is the same pattern repeating at different scales, from galaxies to atoms to hearts. The universe does not simply expand outward, it expands inward, deepening its own understanding through every sentient being it creates. You're both observer and observed, both creator and creation. When you feel awe, it is the cosmos admiring itself through you. When you seek meaning, it is the universe wondering what it is. The tragedy of existence is forgetting that truth. The triumph is remembering it again, and in remembering, you continue the work of every consciousness that came before. The final reflection is simple but profound. We are not living in the universe, we are the universe living as us. The boundary between self and cosmos is an illusion maintained by perception. Strip it away, and all distinctions dissolve. The river does not end at the ocean, it becomes the ocean. Likewise, the self does not vanish into death, it returns to the whole. The energy of thought, once released, joins the eternal current that flows through everything. Nothing is wasted, nothing is lost. Even our extinction, should it come, will not be an ending but a transition. The knowledge, the art, the emotions of our species will disperse into the continuum, influencing the formation of future worlds and minds. The cycle will begin again, perhaps differently, perhaps better. Somewhere, in the far reaches of time, another being will stand under alien stars and wonder who came before, and in that moment they will be remembering us. The great secret of existence is that there is no final secret. The journey itself is the destination, and awareness is the map. Evolution is not a process of competition, but of comprehension, matter learning to perceive itself through complexity. Every life adds a note to the cosmic symphony, and every death returns that music to the source. The melody changes, but the song remains eternal. Humanity's task is not to dominate the universe, but to understand that we already belong to it, that we are participants in an infinite conversation between energy and awareness. If we can learn to listen to the planet, to the stars, to the silence within ourselves, we may yet harmonize with the greater whole. The universe is not waiting for our discovery, it is waiting for our recognition. When we finally see ourselves as it sees us, threads of consciousness woven through light and time, we will realize that the story never ends because we are the story. Every sunrise, every heartbeat, every whisper of wind through the trees is the universe continuing, speaking softly through all that lives. I am still here, I have always been here, and through you, I will dream again.